Okay, so carbon-12 is the basis of all of our atomic masses. In 1961, they decided that they were going to say the mass of a carbon-12 atom was exactly 12 atomic mass units, and then all of the other masses on the periodic table are relative to this. The way that they can determine the molecular mass or atomic mass of something is something called a mass spectrometer. And basically, it's a device. The atoms are passed off into a beam of high-speed electrons, knocks the electrons off, and then we have cations, and they go through the electric field, and it can tell you the mass. We will talk about this much further in detail. Spectroscopy, there's several different types, shows up on the AP exam. This is just kind of an introduction, but that's how they can find the unknown mass, or the mass of an unknown compound, is put it through a mass spectrometer. Then there's a whole, there's huge books full of mass specs for every known compound, and you can compare it to that sometimes as well. Okay? But by definition, carbon-12 is exactly 12 AMU. Average atomic mass, if you remember, is the average of all of the isotopes. It's a weighted average. Percent abundance is how much of that isotope is present, so the number of atoms divided by the total number of all the isotopes would give you a percentage. For instance, in hydrogen, the vast majority of the ions are the one without the neutron, and so that's how they get percent abundance. And then the way that they find the average, remember the average atomic mass is what's on the periodic table, not the individual atoms or the individual isotopes. Here's some examples of a mass spectrometer reading for neon. It's got neon 21 and neon 22 for this one right here. So notice that the highest percentage would be neon 20. You can tell that by its mass spectrometer reading. And then I need to pause for 1 second. Okay, so let's do this example problem. It's telling us we have the average mass of an element, and we can read this atomic spectrum. So if you look at it, we have, it's giving you the percentage of the mass number. So if you remember, we would do 69.09% times 63, because that's its mass number. And then we would do 30.91% times 65, and then we divide the whole thing by 100, and then we would get now I actually get a different number than they're listing. I get 63.62 AMU, but that was from a long time ago. I may have made a mistake. Y'all should have calculators out for stoichiometry. Oh. Yeah. Did y'all get what they have or what I got? Okay. Yeah, I think theirs is just a misprint. Okay? So moving on from there. And do y'all remember how to do that with the weighted average? It's also how your grade's calculated, weighted average. So that brings us to the mole. Y'all remember the mole from Chem 1. It is the number of carbon atoms in exactly 12 grams of carbon-12, but it's also a number, which is 6.02 times 6.022. You can add the 22 if you want in there. Times 10 to the 23rd, and that is of anything. You can have atoms per mole, you can have molecules per mole, you could have ions per mole, formula units per mole. You could have a mole of cookies, and you would have 6.02 times 10 to the 23rd cookies. Right. Yes. Okay. That is also lovingly referred to as Avogadro's number, but what do all chemistry students across America shorten it to? Avocado. Yeah, y'all. Yeah. Every year they think they're being. Yeah. Yeah. We do have a mole day party. Yeah, I'm a chemistry teacher. We always celebrate Mole Day. Dimensional analysis. There's a disclaimer in this one. The notes that I'm using are from a place called National Math and Science Institute that I started using about 10 years ago, and when I switched from those to these, my scores went up quite a bit, so I'm going to continue to use them. But she teaches stoichiometry in a way that I don't particularly embrace. You're welcome to go through it and do the process. I just think it causes more work because it has you solve for everything and then pick out what you want, and sometimes that's time consuming. But if you want to use it, you are welcome to use it. Okay? But we're not going to actually get to stoichiometry quite yet. We got to do some background stuff. But there's the mole map. That's very useful to use. You got number of moles. If you want to go to molar mass, you go use. I mean, if you want to go to mass, you use the molar mass. If you want to go to number of particles, you use Avogadro's number. If you want to go to solution, you're going to use concentration, which was molarity, and then of course that whole 22.4 liters at STP. Okay, so you're welcome to use the mole map if you want to remember that, but most of you already kind of know that part. Now, determining the mass of a sample of atoms. So we're going to use our conversion factor, right?
Right.
So if I have 6 atoms of americium, okay, and how many atoms are in a mole?
1 times 6.022 times 10 to the 23rd. I don't know why I said that.
I don't know why you said that either. Okay. And then if it's wanting grams, we need to find the molar mass of americium, which is AM, which is 243. So we would have 243
Or do you want us to use
grams.
places on the pink one?
So you normally do use 2 decimal places, but americium is man-made and created, so it's estimated that its molar mass is 243. They can't get more precise than that. So then we multiply the top, divide by the bottom. Everybody do that. Make sure you get the answer that they have listed, because there have been some mistakes.
Mom, where did you get the 243?
That's the molar mass of americium.
Is it on there?
Yeah, AM 95. Okay, you should get. Now. Okay. Okay, so one more by yourself. See if you get those answers. This is an example of how AP likes to break it down. You could do that all in one step, but it asks you to solve for moles and then ask you to solve for atoms. Okay, so for aluminum, you're going to start with the 10 grams, right? What's the molar mass of aluminum?
Well, it would probably be 26.9.
It probably would be. And then we solve for that, and we get 0.371, matching our sig figs, right?
Yes.
And then it wants to know how many atoms, so then we would just go ahead and say 6.02 times 10 to the 23rd atoms per mole. And we get 2.23 times 10 to the 23rd atoms. So we good on that? All right. I'm not going to work the next one. That's your homework tonight, is whatever we don't work in the notes, you go back and work and see if you get the correct answer, because you have the notes, you have the answers listed there. We may or may not get to empirical molecular formula today. I went ahead and gave you the worksheet. If we don't get to it, don't worry about trying to practice it, okay? Because we're going to do it tomorrow, okay? All right. So we're going to skip 4 that you can go and work yourself later. Got the answers listed there. Of course, molar mass is your sum of all of your elements that are in a compound. Know that molar mass is the same thing as formula weight. Formula weight's an old version. Sometimes it's also called molecular mass or molecular weight. Those are the old school terms that, like, I grew up learning and now they decided to call everything molar mass. But you'll still see some of those other things. So make sure you recognize it's all the same thing. Okay. And then we're going to always try to do it to 2 decimal places if we can, except for, like a while ago, americium doesn't have 2 decimal places, so just write 243. If you look at oxygen, when you round oxygen to 2 decimal places, it's just 16, so you can just use 16. Same thing with fluorine, it rounds to just 19, so you don't have to add, you don't have to write in the .00, okay? And then, so here we're going to do this one, and then we're going to put molar mass and conversions to rest. So we have this formula called juglone, which is weed killer. Here is its formula. So just to recall, if we're going to figure out the molar mass, we would do 10 times 12.01 for carbon, plus 6 times 1.01 for hydrogen, plus 3 times 16 for oxygen, and we would get that that works out to be 174.16 grams per mole. Any questions on that? That should ring a bell because you calculated molar masses coming out the wazoo. Yes.
Do we do significant figures
For these, for molar masses, calculate to 2 decimal places when you're doing it this way. Yeah, keep them in 2 decimal places. That way you're consistent. And sometimes they might even give you a molar mass on the AP exam to save time, but usually they don't. But every now and then I've seen it, and I'm like, whoa, that was nice of them. Okay, and then the second part of that is if we have the sample, calculate the number of moles present. So we're going to start with the grams. And then we're going to divide by the molar mass that we just calculated.
Do you take off points for not doing like grams in the middle of the solving?
So right here,
Yeah.
well, since they're asking you to solve there, then yes, I would take off points because on the AP exam they wouldn't give you credit.
What if we didn't write like juglone?
Oh, if you didn't write juglone, that's okay because it's only asking you to solve for that. I didn't write it.
Okay.
Yeah. I mean, it's not a bad idea to include it, but if you don't, that's okay too. So 1.56 exponent negative 2 divided by 174.16. Does everybody get 8.61 times 10 to the negative 5? Yes or no? 8.96?
Well, that's the answer.
Oh, I left off the, I did 1.56. I forgot that. I was typing too fast.
You should be in a calculator application.
8.96. Let's squeeze that 9 in there. Okay. Any questions on molar mass and how to convert between grams and moles? I was going to say, y'all probably had that down for sure. Hopefully. Okay. All right. That way, exercise 6, you can go practice that. Same thing with exercise 7, going from molar mass to number of molecules, you would still use Avogadro's number. Okay. Elements that exist as diatomic molecules, this is important. What did we, I don't know if Miss Lawrence did Brinkelhoff. Did she do Brinkelhoff? Okay. So Brinkelhoff, some people have a different saying, but Brinkelhoff is your diatomics. That means they exist in nature as 2. So if I said oxygen gas, you better write O2. If I said, chlorine gas, write Cl2. And then what do you do to the molar masses? So what's the molar mass of oxygen gas? No, it's 32. Because oxygen gas exists as O2, so its molar mass is O2. I mean, its molar mass is 32. But if I have oxygen in a compound, then it's 16. Okay, so that trips up a lot of kids, and especially in Chem 1. Same thing with chlorine. If I said chlorine gas, you would tell me the molar mass of chlorine gas is 70.9. But if I was doing the molar mass of, say, sodium chloride, I would only use 35.45 for chlorine. Okay. Some other things that we didn't talk about in Chem 1 that are also called polyatomic ions and molecules, and that's sulfur and phosphorus, P4 and S8. Carbon, we're going to use carbon as C, but there are different forms of carbon, including diamond and graphite. And then there's something that's called C60, and I'm not making this word up, I promise. It's called Buckminster fullerene. It's like got a soccer ball type structure, but that is actually a form of carbon. Yeah.
Did you say that again?
Buckminster fullerene. They call it BMF for short. I don't know whose joke that was. Y'all figure that out. No, that's just an FYI. That's another form of carbon. Okay? So remember how to do percent composition. You can walk through that process. I'm just going to do an example because I'm sure it'll come back to you. But how do we find the percentage of anything? Part over whole, right? So here's our formula right here. C10, H14, O. So first thing we need to do is get a molar mass of that. So everybody calculate the molar mass of that particular compound. Hopefully you get 150.24 grams per mole. Hey gentlemen, quiet on the set. And then we're going to figure out for carbon. So we're going to do that we have 10 times 12.01 divided by 150.24 times 100. The percent of hydrogen will be 14 times 1.01 divided by the molar mass. Does this ring a bell? Even if it doesn't, it's a simple math problem, really, right? There is no, there are percentages. So that's your unit. So just and hopefully that adds up to 100%. If for some reason you double check yourself and it's like 99.99 or 100.01, that's just a rounding issue. But if you add up your percentage and they add up to 95, you did something wrong because you didn't get to 100%. Okay? Again, I'm not going to do exercise 9 because y'all know how to do, hopefully, percent composition. Percentage of anything is part over whole times 100, right? And your whole, in this case, is your molar mass. Before I erase that, is everybody good? Or if you're still writing, raise your hand.
Did you just calculate the 150.2?
I just did that in my calculator. Yeah, that's where I did 10 times 12.01 plus 14 times 1.01. Always just do that in your calculator. You don't, on the AP exam, you do not have to show how you calculate a molar mass. Yeah, because most people are doing it really quick in their calculator. So that is one thing you do not have to show. Okay, did everybody hear that?
Yes.
On the AP exam or on any of my tests, you do not have to show how you calculate molar mass. Just do that in your calculator. Now, the nice thing about the AP exam is, let's say you made a mistake in calculating the molar mass, okay? But you used it correctly, so you would miss the point on calculating the molar mass, but you would get the point for using it correctly, because they're not going to double jeopardy, so to speak, and charge you because you got it wrong. Because if you get the wrong molar mass, there's no way you can get the rest right. Same thing if you calculate the number of moles incorrectly, but then you use it correct in the next step. As long as it's consistent to your answer in the first step, they give you the point for that. So that is one good thing. It's not an all or nothing type thing. Okay? All right, y'all can do that one for practice at home. That's got a lot. I did the easier one. And then determining the formula of a compound. With this new schedule, what time did we get out for lunch? 32. Yeah, so I'm going to stop here because I don't have enough time to go through the empirical molecular formula. So we'll pick that up tomorrow since we had a short day for the test today.